Welcome to our NPTEL lectures on power quality improvement technique. Today we shall discuss about the multi-level inverter that will be that required to be used for STATCOM as well as this shunt active power filter and also UPQC for also the series booster and other issues. So, we shall start our discussion with the multi-level inverter and why multi-level inverter. So, this will be our content of discussions. We require to cover within 2 lectures for half an hour slots. So, first of all we will talk about the introduction to the multi-level inverter, classification of the multi-level inverter, cascade H-bridge multi-level inverter, carrier based PWM technique for CHB MLI, that is cascade H-bridge and MLI stands for the multi-level inverter. Thereafter we shall discuss about different carrier technique that is suitable for those kind of multi-level inverter. These are the phase shifted PWM, level shifted PWM, hybrid phase shifted and level shifted PWM, third harmonic injection, thereafter asymmetric PWM for asymmetric cascade hybrid cascade H bridge, and then we shall show some simulation studies on it and we will compare the different kind of technique and conclusions. So, these discussions has to be linked with our application part that we will take next, that is the UPQC as well as the shunt active series and shunt filters, active filters, and why you require the multi-level inverter for it. So, as this is an multi-level inverter essentially composed of array of the power semiconductor and the capacitor voltage sources. Array of power semiconductor is generally the diode clamp multi-level inverter, we shall see little later, and the capacitor voltage sources are the capacitor multi-level inverter. And what does it do? It generates the multiple steps instead of the 2 steps. When you have switching on, you have a positive VDC and you have switching off, you have minus VDC. Instead of that, you can have a multi steps. So, voltage waveform with variable and the controllable frequency, phase and amplitude. Thereafter, it generates voltage and current waveform of improved power quality. So, you can, if you are using it for mitigate the current harmonics, so it can precisely track the voltage or current required to be injected, and moreover the switch rating of those devices is going to be reduced, and generally cost of the switch is proportional to the square of the voltage. For this reason multi-level inverter is gaining an attention. And apart from that, when you are feeding adjustable speed drive with a multi-level inverter, and we have seen the effect of the source capacitor that will mitigate the problem of the mainly this reactive power, then it is affected most. So, once you use this multi-level inverter, since harmonic content will be less and thus you will have a solution. We have find the solutions with the multi-pulse converter. Now, we try to find the solutions with the multi-level inverter applied to the drives as well as applied to the banded method, like when you were in a bus, you got a maximum power quality problem, you connect that device and it will mitigate that problem, that is UPQC, unified power quality conditioner, or if your problem is related to you ensure that you are giving a good quality voltage, but you have a problem with the current, then you will generally go for the shunt compensations, and shunt compensation has to be filled up by shunt active power rectifier or compensator or shunt active power filter. So, it can have varied operations. You can have a active rectifier, and that can be made to the shunt active power filter anytime, because topologically they are not different. Once you take it power to the grid and convert shunt active power filter to the charging a battery, then it becomes an active rectifier. And once you feed the power, once you only try to compensate the harmonic part of it, then it becomes a active rectifier. Used for the high power and the used for high power and power quality debonding applications. Because nowadays the problem of the induction machine mostly and the synchronous machine all are the constant frequency machine. Since your supply voltage is constant, this machine will run close to its synchronous speed. But when you require to have a variable frequency operation, you require adjustable speed drive. If it is a scalar, then you require a V by F control. If it is a vector, then you require a flux oriented control or the direct torque control. In all those cases, if you use multi-level inverter, then you can supply high quality power to the drives or the machines. Then sine wave is the best suitable for your machine, because rate of change of voltage is low and it has a least impact on the insulations of the machines. But when you are giving this kind of voltages steps, it has got a very high DVDT, and thus the machine's lifespan decreases. We have discussed all those things in introduction. So, and to reduce it, we will be feeding to the multi-level inverter. So, it has many applications, not it has been contained to the power quality. So, some application are the electric and the hybrid electric vehicle, wind energy conversion, photovoltaic conversion, uninterrupted power supply, reactive power compensations, shunt active power filter compensation, UPQC compensation, and so on. So, practically we are living on the edge of the multi-level inverter. So, features: higher voltage operating capability. It is because the stress across the switch will show that it has been lowered. Lower common mode voltage, we shall see that common mode voltage is between the between these two legs. This is a differential voltage, and another is with the central of the capacitor. The reduce the DVDT, that is what I was saying. When you have a sine wave, if you differentiate, you get cos. So, your sine curve is this, and you have a maximum DVDT at the 0 crossing, that is cos. If you draw the this is voltage, if you draw the DVDT, essentially you get a cos waveform. And when your voltage is less, you got a maximum DVDT, and when you have a maximum voltage, you got 0 DVDT. So, that is the beauty of the sine wave when you fit, and that enhances. It is just like a best substitute, grateful substitute for the machines of a proper sine wave, because it will enhances the lifespan of the machine. Voltage with the reduced harmonic content, it is because you know what you want. You want maybe a particular voltage, 42 volt let us say. Your DC bus voltage is your 100 volt. So, you are essentially you will manage the volt area balancing, because you can apply only 100 volt and till this time, and you will say that this area and this area are equal. Okay, it is equal and that is what the average will be done, but problem lies since they are exactly instantaneously not equal, these inequalities will be filled up by the harmonics, and for this reason harmonic content will be more. Instead of that, let us take a whiteboard. Instead of that, if you have a multi-level inverter where you can apply 50 volt as well as 100 volt, then if you require a 42 volt, you will be applying 50 volt for these durations, and thus you will be having a very close area, this area and this area, instantaneous difference of the voltage will be very closer, and for this reason definitely you will have a least harmonic. So, let us go back, and since you will be pushing out the higher order harmonic, 5th, 7th and all those harmonic can be eliminated, which we have eliminated also in case of the multi-pulse converter, but there the solution was a very bulky and suitable for the very high power drives in a rating, and mostly these are the thyristor driven drive, and you require a power in the range of the megawatt, but here it is in a sub 100 kilowatt or around 100 kilowatt level, and for this drives is been preferred, because you know if you have a 100 kilowatt motor drive, so of course you expect that you will be feeding the voltage in the range of the 11 kV, as simple as that, because you cannot feed 100 kilowatt motor drive from a 440 volt. The reason is pretty simple, you cannot have this much of the current to be flowed into the system, and thus you require this much of the big copper wire, and also the losses and other issues. So, that voltage also will be in that range to have a optimal operation of it. So, for this reason we require to increase the voltage level. As I told you that cost of this device rating is a square of the voltage rating. So, definitely it makes sense to use a lower level devices and thus reduce the device rating and go for the multi-level inverter, even though component counts are more, and thus it increases efficiency and fault tolerant operation, that is also possible. Mostly it is the features of the capacitor clamp inverter, we can find the redundancy if some switch is not working, but that particular voltage can be generated to the combinations of the other switches. So, that is the redundancy or the fault tolerant capacity can be incorporated into the multi-level inverter. So, these are the few features of the multi-level inverter. Now, this is the example of it. Multi-level inverter, we call the multi-level inverter, each phase of the converter has to generate at least 3 different voltage level. Generally this is the first one, you can see that it generally generates plus VDC and minus VDC. We have discussed about the unipolar PWM, bipolar PWM, this is the bipolar voltages. So, either this voltage streak to plus VDC or the minus VDC. In that case, there is a high DVDT. For half bridge it is VDC, for the full bridge it is 2 VDC. So, that is the rate of change of that is the difference of the instantaneous difference of the voltage, and also rate of change of voltage is extremely high. So, for this reason you can generate this voltage and ultimately you can map the volt area curve and find out the sine wave in between. And thereafter this is the B, this is a 3 level. So, here you can see that in between there is a neutral midpoint of the supply voltage, or it is not available, you have to split by the capacitor and this put the midpoint and generate the midpoint. And here what happen, you can connect plus VDC, you can connect minus VDC, and also you can connect to the neutral point, and thus you get a 3 level. So, this is the generally we also say the multi-level inverter, 3 or the 3 level inverter. And this is the multi-level inverter, you can have a different level and you can split this voltage like this, and ultimately you generate this waveform. You can see that it has a very low DVDT, and the number of switches required will be more, but it is very close to the sine wave, and requirement of the filter will be reduced, low DVDT, all those advantage will be there. And since this switches has to block only the V by N, VDC by N of this total voltage, the voltage rating of these devices also going to be reduced. So, this is the classification of the multi-level inverter. One, it is a multi-level inverter. So, you can have a single DC source. These are mainly classified into the neutral clamp, that is a direct clamp also we say, and there is a flying capacitor. And also you have it require a multiple DC sources. This is one of the disadvantage of this topology. So, you require not single sources, all the sources required to be different, and otherwise short circuit will happen. So, there is a research to provide single source based multi-level inverter for cascade H bridge, but that we are not discussing here, we are taking the simple conclusion of it. And thereafter we require to have a many this is one of the solution we look for in the solar cells, because solar cell can individually generate power and ultimately it can do the needful. So, thereafter this can be a cascade H bridge multi-level inverter. This is said to be that it can, all these receivers may have a equal voltage or it may have an unequal voltage. It can be a binary strings also, that is very famous for the solar application, because you can step it up and you will give it like that. And this cascade multi-level inverter also used into the UPQC, a shunt active power filter, and any other applications also, because ultimately you just require a difference of receivers voltages to compensate a different level of voltage level. So, all those applications are nowadays we prefer this application more than this neutral clamp and the flying capacitor. It is because of the building block. You take a H bridge, that will be a building block, you put them in different way and thus you can get any level. So, that is the one of the advantage. It is because of the brick structure. So, this cascade H bridge multi-level inverter is been preferred. So, this is the direct clamp or the neutral point clamp MLI. As I told you that this will have a neutral point to diode, and how you will come out with this logic, and generally what happen if you go back here, this is the 3 level inverter and that realization has been shown. Once you connect this switch at this point, so within that required to block the voltage of VDC by 2, and within that it required to block the voltage of VDC, and current can be bidirectional, that is the feature. Same way, when you put this switch here, then also you are blocking the voltage of minus VDC by 2, plus VDC by 2, and the current can be bidirectional. Same way, upper one will be just replication of the reverse one, just changing sign. So, how these features can be incorporated in this the circuit we discuss. So, let us say that this point, this is a point of interest, required to connect at the point VDC. Once you connect this point, as you understand, S1 and S2 both require to be shorted. So, both will be on. So, once they are on, so you get the voltage of 2 VDC or the 2 VDC, let us say, because we have considered that this voltage to be VDC and this voltage to be VDC. So, you are at this point you are getting 2 VDC, fair enough. Now, if you want to connect this point here, this point to be connected here. So, depending on the polarity, whether this voltage let us say V A is greater than V N, then so you will trigger this device and this device. Previously S1 A and S2 was on, and then S2 and S1 prime will be on. I can tell you little later that, as you have seen, that this switch and this switch are complement, this switch and this switch are complement. Ultimately, your control circuit is quite easier. So, just NOT logic will work, they are not independent function. So, what happen? You will getting this SA2 and SA1 prime. So, depending on the which voltage is positive, it will take the path. If VA is greater than Vn, then what will happen? So, ultimately this is on, this is on, this will go back like this. If the reverse happens, this voltage is more than this voltage, generally it happens in the negative half cycle. So, then if reverse happen, this is that Vn is greater than Va. So, then essentially current required to flow, then current will flow from this point to this point through this diode the SA2 and through S2 and ultimately reach here. Similarly, other switches are followed, and here thus reverse will happen and you will get a current, because another thing, if you want to connect the minus VDC by minus VDC, then you require to on SA1 prime and SA2 prime. So, in that way this voltage can be generated and you can connect. So, thus we can brief out our discussions in this way. Let me again change the color of the pen to red. So, only 2 switch per legs receive the getting signals at a time. Switch pairs SA1 and SA2 receives inverted signals to avoid the decoupling circuits. One of the 4 binary combination SA1 and SA2 is not used, since it does not provide the current path to flow the load. You can see that all the switches, all the switching device in 3 level neutral point clamp or the direct clamp inverter needs to block only the half of the DC bus voltage. Thus, you have a uniformity in the bill of material, in abbreviation we call BOM. So, you require to purchase all the IGBTs of the same rating, and that gives you your component, reduced component count of your bill of material, and also as I told you that if you use the IGBT rating of VDC, then cost was 4 times higher. So, you require to purchase, so ultimately if the diet, if this IGBT price of VDC by 2 is X, then the cost of the one leg is 4x. But if IGBT price is VDC is 2x, then 2 IGBT you require, it is again 4x. So, cost wise rather we do not have much problem, and from this and the, but in terms of the benefit, you get lower THD, lower value of the filters, greater longevity of your devices, and so on, all those advantages. So, let us see that how does it work. That I tried to explain here, that when we want that it will get VDC, then upper two switches S1 and S2 will be closed, or you can write S3 as S1 prime and S4 as S2 prime for this direct clamp MLA. So, you want this voltage, as I told you, you close these two switches. Now, it will be assignment for you when the voltage lead or lag. Let us say this is your voltage lead or lag, means once you connect you get a plus VDC by 2 plus VDC. But generally what happen, so since you are tracking the sine wave, you generally do not apply this high voltage at the beginning. So, generally you will have a half voltage here, from there onward you generally have have this big voltage of VDC will be applied. And for this reason, if you do not have extremely poor power factor, generally it is in StatCom, this is a challenge there. Otherwise, voltage and current both will be positive. Only in StatCom they are 90-degree phase shifted, so there is a challenge, because one voltage at its peak, then current is 90-degree phase shifted. Otherwise, current and voltage will be equidirections, and that has a that generally happens. But current and voltage, if current is positive, voltage is negative, then there is a big challenge, because ultimately current you apply this voltage, ultimately VDC will come here, and we expect that current to flow also this way. But if you wanted to current to be reversed back, ultimately it will go to the diode. So, I just use and that is only for few cases, that is the direction of the current also, most of the cases. Now, and thus you get a voltage, and most of the cases if you have this, generally you apply this voltage very close to the after 45 degrees. So, voltage and current will be positive, and here there is a challenge. Sometime this voltage ultimately you are applying 0, maybe more, or sometime this voltage will be more. If it is a positive half cycles and you apply it, then you expect that this voltage is more, that means V A is more than V N, then thus what happens, the lower switch will conduct. Previously what happened, thus this will go out and this will come in, and ultimately this will be the path to flow most of the cases. And in negative half cycle what will happen, mostly when this voltage is less, then upper switch will turn on and ultimately voltage will come from this to compensate or mitigate to the 0. So, this is the way of functioning, and this is the same thing for the lower half cycles or the negative half cycles. Thank you for your attention. I shall continue our discussion in our next class.